Okay, hello and welcome. We're going to be talking about section 1.1b. And so let's take some notes together. And so here we go. If we've got, we're starting a new topic in mathematics. One thing you should know is that there are some undefined terms. Okay, and so in geometry, these basic undefined terms are going to be point, line, and plane. Okay. And so what we'll have would be a point is a location. Okay. Normally I think about a location to be a location that has no shape or size. And I would say like a point in time or a point like on a map. Okay. It's right there. Okay. And so it's this, and so like on a graph, you notice we graph ordered pairs. Okay. And say, hey, how would you get to that point? You'd go left two and down one. So it'd be an ordered pair to get you there. We also can call it by a name. Okay. And so to name a point, we're going to say, okay, any shape needs a word. So you would say point, and then you would say B. Okay, so that would be the name of this would be point B. A line, you graphed lines back in the algebra one. And so a line is comprised of infinitely many points. However, when you graph a line, we can write the equation of it, but also sometimes we're not on a graph. We want to name that, not by its equation, but we want to call it and say, okay, that line right there. Okay, and so how you name a line is you take any of the 2 points on it. Okay, because 2 points determine the way that a line will go. You have to start someplace and head a different direction. Okay, and so you would say, and again, a line is a shape, and so you would say point actually lies, sorry. You would say line PQ. That's one way to do it. Now, I am a math teacher and I don't always love words. And so we do have a symbol that talks about a line. So if you mean a line that goes through P and Q and goes forever in both directions, you would call it line PQ. If you meant you can use a symbol above it to talk about a segment. You can use a symbol above it to call it an array, and we'll talk about those later on. But for the time being, we're going to talk about the line that goes through P and Q and goes forever in both directions. So that's how you abbreviate those values. And then the last thing is notice over here, this line, not all lines have a nickname, but this one is called line M. And I've got a nickname. My little nieces and nephews call me Aunt Shell. Okay, yeah, my name is Michelle, and but they abbreviate it because it's such a long word. And so this has a nickname too, and we can say line and use the lowercase m. It's the nickname that this line has. Not all of them have it, but this one does. Okay, and a line goes forever in both directions, has infinitely many points that you just need two of them to name it. Okay, and so the next thing is a plane. And let me make sure this is recording real quickly. Let me see if that is. Yep, we got this. So for a plane, is a flat surface like your desk, okay? And that's a good start to a plane. A plane is a flat surface, but unlike your desk, it goes forever in a flat direction, okay? And so has infinitely many points on it, but it is a plane, okay? And so this right here, it's hard to draw something that goes forever. So you just start with a parallelogram and you put some points on it, or put some shapes on it. So that's a plane over here. And how you name it is, and this is a little weird, so I want you to listen carefully. Okay, it's a shape, so we're gonna say plane. And I don't think there's a symbol to help you like abbreviate plane. So you got to write the word plane. And what you have to do is you have to pick 3 points on this plane to name it. And they can't be collinear. Okay. And I'll tell you why. It's a little weird, and if you're in class, we'll kind of do a demonstration. If I have 3 people of differing heights stand up like from the same table group, and I place, imagine it's kind of weird. If I place like a piece of like drywall or like a big, flat like MDF or like a plywood type board on top of their heads, it will kind of slant depending if one of them shorter than the other two kids that I have stand up. But there's only one plane. If their top of their heads would be the points on it, there's only one way that will slope if they just stand up at their seats. So 3 points that are not in the same in a line with each other, you can place a plane that intersects with all 3 of those points, and it only goes one way. So you'll notice it kind of just rests on their head in one specific direction. And so you name a plane by taking 3 points on that plane that are not in a straight line. Okay, and so this would be plane, maybe B, Q, and C. You could just pick any of them. Or if it has like an artist, like somebody's signed it in the corner, you can notice there's a fancy letter there. You could call it by that nickname, Lane, and that'd be K. Now the truth is they can't be in a straight line. Okay, and I can kind of try to show you why. If you had three people who stood at the front of my room, okay, and they stood in a straight line, you notice you could place that plywood on top of their head and it could rotate back and forth, like dipping downwards or slanting backwards. There's many ways for a piece of plywood to be balanced on their heads. But if I made those kids stand in a triangle and I placed the plywood on top of their heads, there would be only one way for that plywood to rest. So if you want to name a specific plane in a specific slant, you've got to have non-collinear points as you name it. So it's a little weird. You just have to make sure you follow those rules if you mean talking about a specific plane. And then this is the coordinate plane that you guys used in algebra. The next thing is, those are undefined terms because they're kind of the essential building blocks of vocabulary. Defined terms are going to be ones that you kind of bring things together, like a triangle. It would be that where you can say, okay, a triangle has three sides, three vertices, three angles, and there's certain properties that work on triangles. So let's start talking about things that are going to have properties. They have some special things that happen if they have them. Okay, any 2 points are going to be collinear. Okay, so if I say, are these 2 points? Any 2 points are a potential line. So any 2 points that you pick in the whole world can be connected. You can go anywhere you want in the world. You just have to go from point A to point B. That will be a line. Okay, and then the next thing is going to be collinear points. Like A, B, and C are going to be collinear. And so you would write, give me some points that are collinear. You'd say points C, B, and A. Okay. Now, not collinear, okay, you need to give 3. If you just say 2 points, like D and C are not on the same line. Well, yet, but you could connect them with a line that you draw. Okay. So you have to give 3. So you would say, okay, points C and then B, and then you have to make it rec. We're like, okay, C, B, and then D. Those don't form a straight line. Okay. So if you just give me 2, those will always be collinear. But if you give me 3 and you have to like bend a corner and be like, I wrecked it. So those would be not collinear. Now coplanar, okay, if they're on the same plane. So the truth is this, if I take any 3 points, I can form a plane between them. Okay, and so if you want to talk about coplanar, you would say points, any 3 points. Okay, but if points B, C, and D, yes. Okay, those are all on the same plane. Okay, now if you just say points here, if you even say X, Y, and B, no, they're not on the same drawn plane, but you could actually finagle a way to connect this, and this, and to make like a plane like that's kind of horizontally, like a triangle. That doesn't look very good, but you could kind of connect them and make like a flat surface there. Okay, connecting those 3 points. So don't just give me 3, you've got to give 4. So again, give me 3 that could make a plane. So X, Y, and Z, and then you have to throw a stupid one in there like and B. You can't connect those to make a plane. Now, in general, any 3 points can make a new plane, okay, can be connected. But so that's why you got to give me 3 that are, and then 1 that can't join that club. Okay, so that's how you do coplanar, or not coplanar. Okay, so let's go through some examples. And this will be good practice. As we work, say name a point. Well, a point is a shape, and so you have to write point, and then pick any point you see. Okay. That would be like M. Okay. The only 2 you wouldn't put would be this B, that's the name of the plane, and this A right here, and that's the name of that line. Okay. Name a line in 2 ways. You could write line, and you could call it line A. You could say line like JK, or honestly, we've got a symbol for lines, and that would be give me 2 points on it, JK, and put the line with arrows above it. That means I'm thinking of a line that goes through points J and K, and it has more points on it, obviously, but you just need 2 of them, and then you put a line above it to signify it goes forever, including those points. Name a plane in 2 ways, okay? To name a plane, you have to have 3 points on the plane, And if you want to name a specific plane, okay, again, remember, if you have points in a line, there's multiple planes that could be drawn through this. You could draw like a vertical plane, that goes through this right here. And so the thing is, you cannot name a plane with, erase this, see if I can make that go. You cannot name a plane, a specific plane. If you want to name this blue plane right here, you've got to use 3 points that are not in collinear with each other. So you would say plane. Again, planes are shapes. You could do J, K, and M. Okay, not collinear. Because if you want to say that plane right there, not just any plane that goes through those points, there's a lot of points that go through it. Okay, so you want to be not ambiguous about that. You want to be specific and be like, I want that specific blue plane that's drawn right here on this paper. Okay, so you can do that. Any 3 points that are not collinear on that plane, or you could call it by its nickname, plane B. Okay, because it has a nickname, like an artist signed a picture. Okay, let's name some geometric things that could be this. Okay, a patio. So like out back on your in front back of your house, if there's like a cement patio there, what would that be? That'd be like a plane. A button on a table could be like a point. A yardstick could be like a line. Okay, and then 2 connected walls. Okay, those are 2 planes. And then the edge of a table could be a line. And then let's look at these. How many planes appear in this figure? Okay, so let's chat about this. Well, I spy the one flat surface like the table is on. And then if you count the ones that are on this pentagonal pyramid, yeah, it's a pentagon pyramid, because it looks, it's pointy at the top. It looks like there's 1, 2, 3, there's 5 faces there. So there are 6 total, okay? So 6 planes on this figure, the flat surface, and then the 5 that are on the faces of the pyramid. And these planes that are drawn could go forever in that flat direction, but they're only shown for a specific dimension. And so, okay, points H, I, and who are not collinear. So if you start with H and you go towards I, we want something that isn't collinear. So if you said C or F, you'd be wrong. But C, H, I, and say B would be an example of something that is not collinear up here. Because notice they can't form a straight line if you connect those 3 points. Okay, there are many examples of things that you could put for that. That'd be right. So H, I, and who would be collinear. Well, if you would keep going straight with H and I, you could put C or you could put F, and each of those, your line will be connected. C, or like you would put F, depending, would be collinear with H and I. Okay, because you can form a straight line with those values, okay, with those points. Okay, plane P and plane ACD. Okay, so plane P is the flat surface, like the table. And then plane, they're talking about ACD. Okay, that's this one right here. Okay, where do those 2 planes meet? Okay, 2 planes, if they meet, okay, if they're parallel, they don't meet. Like 2 pieces of bread, if you have a lot of meat between the piece of bread, those planes won't meet because they're separated. They're parallel to each other. But if they do meet, they're going to meet at a line. Okay, so notice the seam where these 2 meet would be, and you could call it segment CD. You see that? Because it ends, it's just the segment between C and D, or you could talk about the line where they meet, okay? Because we could draw a line that goes forever in both directions. So we could either talk about the line that goes forever between C and D, or just the segment between C and D. And I'm not going to be real picky about either one of those, but CD is where those 2 connect, okay? The next one, where does plane ACD, that's this one right here, intersect with plane AEF? So let's find AEF. That's over here. They look like I'm using the same color, but one of them's green, one of them's yellow. Where do they meet? Do they meet? Well, yeah, they do. They meet at point A. Okay, awesome. And then let's check and see this next example says, no, let's summarize first. 2 lines intersect to form a point. So if 2 lines meet, if they intersect, they meet at a point. That's where they overlap. That's where there's a point in common if 2 lines meet. 2 planes intersect at what? Well, if you think about the corner of my room, okay, if you've got 2 flat surfaces, they meet in the corner and they meet at a line. Okay? Because you could extend it forever. You could call it a segment or you could call it a line. Okay. Let's see if we can follow the directions here. It says, and part of geometry is hearing the words and being able to read what you hear, or read and then hear like in your brain what you should do. It says line QR is comprised of Q, who is at -2, 4, and R, who is at 4, -4. So always name the points too. So this is Q, sorry, Q and R. So this is a line. So we should say, okay, it goes through these 2 points, but it does go forever, okay? And then also we need to say, add point T, so it's collinear with these points. What's that mean? Collinear means it's on the same line with them, okay? There's a lot of places you can put it, okay? You could put T between them. You could put T over here on this side. You could put T on as long as it's on the same line, it doesn't matter, okay? Draw segment AB. What's a segment, woman? Well, it contains points A and point B, but instead of going forever, it stops at A and B, okay? And line CD, okay, so we're gonna draw a line that goes forever in both directions, but I want these 2 pieces, these segment and the line, to intersect at point M. So we're gonna draw them not parallel, we're gonna draw them to be intersecting, and where they meet is going to be at point M. And so let's name this next one, it's CD, so 2 of the points on there have to be C and D, and they need to meet at point M. So notice point M is on both of these shapes, okay? So we're getting there, right? And then 2 planes that contain line T. Okay, so 2 points have a line in common. Well, that means that's where they intersect. So one way to draw it is kind of like the walls of a classroom, okay? And so you can say, or a room, and they contain or meet at line T. So you have to name this to be line T. Okay, so we got 2 planes that contain line T. And then it says draw plane R. And how we draw a plane is just use like a parallelogram. So you take plane R, we'll name it to be R, like sign it like an artist. And it contains CD, line CD. So you got to put C on there and D on there. And it needs to be a line going forever in both directions. And then point B lies on CD. So that means we just have to grab B right here and just put it on the line and on the plane. Okay, so if it's collinear with C and D, it's also going to be coplanar, as well with them. And so there's no way to be a little higher, a little lower than that plane if it's on that line. How could 3 planes intersect? Well, in 2 ways. If you've got a classroom, if you've got 3 planes, think about the 2 walls and the floor. They could meet at a corner at a point. That's one way. Another one is kind of hard to draw. If you ever watched Finding Nemo, you know how they escape is through the filter, right? The fish filter. So if you draw yourself kind of like a fish filter, and this is hard. The thing is, you kind of draw like a plane kind of coming horizontally there. And you can draw another one kind of vertical with it. I'm kind of terrible at this, but okay. And kind of goes below a little bit. So like you can think of like a spinning wheel, like a filter. Now how these meet would be at a line. And you can imagine it kind of spinning. So if you can't draw it, that's fine. But I want you to know 3 planes could intersect, have a common point where they meet, being at a point or being at a line. All right. Well, thank you so much. I hope you guys have a good day. I'm going to see if I can stop this video. Let's see if I got it. There we go.